We're going to find out if this series is convergent or divergent, so we're going to use the ratio test. With the ratio test, we have the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. And we want to find out what this is. If this is greater than 1, it diverges. If this is less than 1, it absolutely converges, or converges absolutely. If it equals 1, then it tells you nothing. It's inconclusive. It's inconclusive. So let's find out what our a sub n plus 1 is. Our a sub n plus 1 is going to be whatever we get where we plug n plus 1 for all n's. So it would be this. Like that, factorial, right there. So we would have to distribute the 2. We would get 2n plus 2. 2n plus 2, and we would distribute the 2 here. So this would be to the power of 2n plus 2. This is a sub n plus 1. A sub n is what we had up there. And we're going to divide by it. We're going to divide by a sub n and absolute value everything. So since we're dividing, we know that we're going to multiply by the reciprocal, because that's what division is. So we're going to do that. We're going to multiply by the reciprocal of this. And remember, that's unchanged in its n's. Pi to the power of 2n. This is going to go away anyway, because we're absolute valuing it. We absolute valued this thing, and so this stuff went away, and it also went away for a sub n plus 1. And we take the limit as n approaches infinity. We can start to cancel stuff out by first grouping and seeing more clearly what does cancel out. So this would be 2n factorial over 2n plus 2 factorial times pi to the 2n plus 2 over pi to the 2n. So with this one, we can expand this. We can expand this to see that what factorial means is that we're multiplying by the previous integers. So this would be 2n plus 2 times 2n plus 1 times 2n factorial. Because we're just subtracting 1 each time and multiplying by it. So therefore, this 2n factorial cancels out with this one, and we're left with this 1 over 2n plus 2 times 2n plus 1 there in that denominator. This one, we also have some cancellation going on because this is pi to the power of 2n times pi squared. So these cancel out, and we have pi squared being multiplied to this. We can bring it over here to replace that 1, and now we take the limit as n approaches infinity by actually plugging in infinity. And if we plug in infinity into there, it's the only place we can plug it into these little variables. So we get infinity. We get infinity down there, and anything divided by infinity, any constant like that, pi squared divided by infinity, gets obliterated into 0. And so 0 is less than 1. It's less than 1, so therefore this absolutely converges. This absolutely converges because 0 is less than 1. By the ratio test, this converges, absolutely converges.